All right, thank you. Let me just test to see that this is working. Okay, great. So as Ali introduced, my name is Brian Keng. I'm from Borealis AI. Borealis AI, if you didn't know, is a AI research institute at the Royal Bank of Canada. And I also hold positions at Rotman as an adjunct professor. So before I begin the main part of my talk, which is a lot of the lessons that I've been learned at Borealis and before about how to deploy AI in the enterprise, I wanted to just give you a little introduction to Borealis because I think it's really relevant to what Vector is as well as the community we have in AI in Toronto. So at Borealis, what our mission is to create real-world impact through scientific pursuit. And what this really means is that we research, we design, we build AI technologies to transform RBC and shape the future of finance. This is really our ambition and what we've been doing since our founding in 2016. A little bit of background. We were founded in 2016 and a very small team initially. And now we've grown to over 100 AI experts. 10 live products deploying, generating hundreds of millions of dollars of value across the bank. And we have not just researchers, we have a lot of PhDs, but we also have product people, engineers, and business developers to help engage with the 90,000 person organization that RBC is. We have a bunch of GPUs, as you would expect, because we're doing a lot of neural networks and deep learning. We also do a lot of research and give back to the community in forms of publishing, as well as a lot of patents and academic partnerships, which I'll talk about in a second. Now, one thing I just want to stop here, because Ali mentioned it, and I think this is really important for all of us here in Canada, is that we've traditionally been very active and very successful in the academic realm in the area of AI. One of the places that we've not been as successful is in commercialization and really transitioning that to the industry. And one of the things I'm really proud about at Borealis AI is that we now are on the global stage. We are the top in Canada, but moreover, we're actually number 3 in the world across 50 global financial institutions, including heavyweights like JP Morgan, Goldman Sachs, Morgan Stanley, and we still rank 3rd. And I think this is a testament to both the talent that we have in the Canadian ecosystem and I think our ability to be able to transition that to the industry. And so I think Borealis is one of the one of the examples of that, and I hope to see many, many more in the future as well. The other thing that I want to call out is Vector has been a great partner to us, and since the beginning, we've really been thinking about how to not just develop Borealis AI, but develop the ecosystem within Canada. So we have partnerships with all of these different institutions, and we do many number of things from research collaborations to different funding to different talks like this. And one of the things we want to really build here in Canada is a better ecosystem, both on the academic side and on the commercial and industry side as well. And to that, one of the things that we want to develop, particularly for us, is the talent. So we have a lot of research internships where we bring graduate students in to do fundamental research for us. We also hire a lot of co-ops. Beyond that, we fund a lot of research for graduate students, and we have an undergraduate mentorship program to develop that early generation, getting into AI so that we can really identify and grow talent from the start all the way to maturity. Now, before I get into the main part talk, I want to talk a little bit about research and products, because I think a lot of us here understand the research side coming from academia. A lot of us probably understand the product side coming from industry. And Borealis is a bit of a unique institute where we're mixing both. And so I want to talk a little bit about both because I think it's interesting. So first of all, on the research side, this is really where our roots came in. We hired a lot of researchers to begin with, and we did a lot of publications to start. And we still do a lot. We still participate in a lot of different conferences, publish papers, and that is still a core part of what we do. But one thing that we realize is that it's not enough just to publish papers. We need to figure out how to transition that to the industry. And so as we were developing the products, one thing we started to realize is that there were strategic research areas for us to focus on in order to concentrate our research and really add value back to RBC. And so we have these 3 North Star research areas that we focus on. The first one is on this idea of asynchronous temporal models. And the idea is that time series typically are very evenly spaced out. But oftentimes you have data that's not evenly spaced out. For example, financial transactions that kind of occur randomly. And so how do you take this model, this data, and utilize it in a model so that you can model the customer, model the behaviors very accurately? And on a relative basis, there's a lot less of this data or this research in the industry, and something that we found that we needed to focus on. The second area is in non-cooperative learning, or competitive learning in our capital market space. So instead of just predicting something, you actually are predicting something in an adversarial environment where people are actively trying to exploit what your model is doing and some of its weaknesses. And so trying to develop strategies and modeling the dynamics of a market are really important for some of the work we do in capital markets. And so this has been another key area for us as well. And then the last area of causal machine learning has been a big focus for us because unlike maybe internet companies that have millions or billions of pieces of feedback every day, we actually have much longer timelines for feedback. Think about things like getting credit and seeing if there's a default at some later point in time. And so we have a lot of observational data, and because of this long feedback cycle, we have to think a little bit differently, more on the causality side, about how to model it and properly identify some of the patterns so that we can make better decisions. So on the research side, as I mentioned, we have a lot of publications. These are just a list of the ones that we've done in last year, and we have a bunch more coming this year. We really want to engage with the research community, not just to give back and not just to advance our research, but also to make sure that we're staying on the cutting edge, because a lot of the problems we're tackling, because the data is so unique, has not really been penetrated by the academic realm. And so we really want to stay on the edge so that we can contribute back and leverage some of the newest techniques towards that. Now, the other side, that was the research side. Now, the other side is products. And so one of the things that we've identified very, very early on is that you need way more than researchers to develop a good product. And so this is why we built these cross-functional teams with researchers, but also with engineers, with product managers, with business developers, so that we can properly engage with the rest of the enterprise, figure out what the problems are, do that algorithmic research, but then also deploy it to production as well. And so we actually work across almost the entire bank. The 4 different areas I have listed here are personal and commercial banking. This is kind of the retail banking you're aware of, as well as larger commercial entities, like small and medium-sized businesses. We work in risk, which is a separate department to manage all of the risks that we have in the financial institute. We have the capital markets, which involves investment banking, involves sales, trading, and advisory, as well as wealth management, which is also a big part of RBC. And so what we're really looking for here is problems that we can tackle with AI that can make huge impacts to really transform the businesses and, at the end of the day, generate a lot of value for the business. Now, unfortunately, because banks are so secretive, I can't really talk about everything that we've done there, and although I would love to, but I can talk about a couple of examples that we have talked about publicly, and I think that gives you a flavor of some of the things that we've done. So the first one, if any of you are RBC customers right now, there's this feature within the RBC app called Know Me Forecast, and if you go look at it, it's actually pretty good. What happens is that there's a little tab, and it will predict your cash flows for the next 7 days. And it can predict really easy stuff, like your internet bill is always on the 15th, but it also can predict things that aren't so obvious, whether that be income that's coming in, or perhaps Interact e-transfers you do on a semi-regular basis. And what's really cool about this is a great example of that ATOM, or asynchronous temporal model research that we've been doing. We use the transaction data to predict what's going to happen in the future. And as a result, RBC app has been nominated for awards, and Know Me Forecast has definitely been called out as one of the key features driving some of that innovation. The other example that I think is really interesting is Aiden. And so this is in the capital market space. The problem here is really around trading large blocks of stocks. So say you're a pension fund, you want to trade 1 million shares to Google. You can't just dump your 1 million shares on the market, or else the price will be distorted too much. And so what you want to do is space those out over time. And one of the earliest successes that we had at Borealis was building this reinforcement learning algorithm of Aiden in order to space those trades out and decide when to execute different trades. And this has been such a big success in collaboration with our capital markets partners. This has become one of the major platforms in capital markets to do this type of work, And so we're really proud of the work here, and I think really showcases some of the innovation that we had, where I think on a relative basis, reinforcement learning hasn't been deployed as widely into the industry as other types of technologies. Now, I probably wouldn't be doing my job if I didn't put this slide up here, because I think we're all really looking for good AI talent, and we are especially at Borealis. So if you're a researcher, an engineer, product manager, or a business expert, we'd love to talk to you, especially if you want to work on that intersection of AI and finance. You can head to our website, or just feel free to shoot me an email too. I'd love to talk and see if you're a good fit for Borealis. Okay, so that was just a basic introduction. Now I want to get to the meat of the talk, and this is really, I've broken it down to 3 different lessons I've learned deploying AI into the enterprise. The first lesson is not every problem can be solved by AI. And so this is maybe not exactly what you're expecting, but let me try to dig in a bit deeper. This is a little bit of a joke I like to put up, but it's a little bit scary how well this correlates with some thinking of executives, particularly people who aren't very familiar with AI. Step 1, take whatever the latest AI technology is. In this case, we have LLMs like ChatGPT. Do something in between, and then just make a lot of money. And so, this is ideally what we'd like to do, but, we need to really dig into what that step 2 is and understand, is this even possible, and what are some of the nuances there? So the first thing I like to start with whenever I talk to executives is really this idea of interpolation versus extrapolation. And I have this example here, which I think gives a good intuition. So I took an image classification model that tells you what a description of the picture is, classifies what the picture should be. And I took the model that was trained on ImageNet, which many of you are familiar with, but it's basically a bunch of pictures and natural images. So in this case, I just pulled out some of them that are relevant to this example, which are dogs. Now, I have 3 different examples I'm using the model to try to classify what the picture is. So the first one is a golden retriever, and the model says it's a golden retriever with 80-something% accuracy. So very good, does really well. The second picture is a picture of a miniature poodle, but you kind of might get fooled because the poodle's wearing clothes, and it probably hasn't seen this exact picture before. And so when I put it in, it actually still gets 70-something% accuracy. And in fact, the second most highest confidence one is actually toy poodle. So again, model did really, really good. But the problem kind of comes in that last one, where it's you and I know it's a picture of a dog, but it's a picture of a cartoon dog. And what does the model guess? Mask. Obviously not what you're expecting. And then actually the second best guess is ladybug, which is also kind of off. And I think this really gives some intuition that the model is not doing what you think it is. It's not learning in the same way that humans learn. What it learns from is specifically the data. So if you have something that looks like the data and in some sense interpolating from the data, it does a pretty good job. But if you have something way outside, far away from the data that you gave it to learn, it's not going to do very well. And in some abstract sense, if you extrapolate, it's not going to do well on this type of data. And just to drive this point home, because it's so important to give intuition about what machine learning can do, I also have some contrived examples here where I'm trying to fit different models to a 2-dimensional data set here. And so what I've done is in the middle, I've split the data on the left-hand side of each panel to things the model is trained on, and the model is trying to predict what's supposed to happen on the right side of each one of these panels. So the first example here, I have what's called a simple linear model, which I did some feature engineering on. And you can see that yellow line basically just, once it passes that halfway point, when it's predicting, it goes to negative infinity. It's obviously not the kind of prediction that you want. And the middle panel does a little bit better. It's a neural network. And so it kind of gets the trend right, but the slope is totally off. It also didn't catch that sinusoidal pattern that you see. And then on the last one is a popular model called the random forest. And again, it kind of just predicts a constant value. And so all this is to say is that you really need to think hard about what machine learning can and can't do, because if you don't have the right data, if it's not related to the data that you're trying to predict on or do inference on, you're going to get really weird results. And it doesn't matter if you're using kind of these simpler models on simple data or something even like ChatGPT, where if it's doing something it's never seen before, it's probably not going to do so well. So that's one part of it, which is just fundamentally what is the model doing, how does it actually learn. But there is a second part that I want to talk about, which is something that I come across in the industry that I think a lot of people coming from academia have a lot of trouble with. So it's really this translation problem. At the end of the day, what we really care about is affecting business KPIs. We don't really care about how accurate your model is or what loss you have. We just care about affecting the business KPI. And I want to try to explain why this is not such an easy thing to do. So on how the model learns, there's this mathematical expression called the objective function. This is something you're trying to minimize or maximize. Kind of tells you what intuitively is a good fit for the data, matching the patterns, and what's kind of a bad fit. And for technical reasons, what we put in that mathematical expression is different from what we typically use to evaluate the metric. So for example, in the images example, you might use accuracy as an evaluation metric. So already, even on this technical level, we have one level of indirection from what the model's actually learning to what we're evaluating it on. But actually, the bigger difference and the bigger jump is once you go one step higher. When you try to translate that, do that translation from that business KPI like profit or sales or cost reduction down to your evaluation metric and then eventually down to your machine learning objective function. And this translation is so difficult and something that we're really not taught in school either. And in many cases, it's either not perfect or even not even possible at all. And so in these types of cases, especially the ones that are not possible, or it's too loosely correlated with their final metric, you should really think twice about whether or not to use machine learning, because if you use it in these cases, you actually might be trying to optimize the wrong thing. Now, I don't want to leave on such a sour note, but I think what we really need to think harder about what we can use machine learning and AI for. Really, to drive all of that profit that we want, we got to think very hard about the data. Are we using the right data? Do we have the right data for the model to learn the right thing? And then also put together the right team that can help you with that translation. It's not just PhDs. We also need people who understand the business, who understand some of the implications about the process, about how things actually work. And then because we're working with data ahead of time, we can't know if the problem is going to be solved by machine learning. We have to build prototypes to test that feasibility and really understand, can we solve the problem using machine learning and AI? Okay, so that was the first lesson. Really, not every problem can be solved by using AI. So the second lesson I have here is not every problem should be solved by AI. And so I want to tackle this from a couple of different angles. So I think everyone's seen a graph like this. These are exponential graphs. On the left-hand side, data is growing exponentially. Right-hand side, in this example, I have parameters of models are growing exponentially, but you can put flops in here, whatever you want. Compute is growing exponentially. And things growing exponentially get pretty big and pretty expensive really fast. And this kind of leads us to this fact that we really need to think about costs here. It's not just whether or not we can solve it, it's whether or not we should solve it. Data is getting expensive, whether just getting the right data and labeling it, or just storing it. Even now it's getting very expensive. The compute, very expensive. GPUs are very expensive and even hard to get to right now. Talent, of course, is very expensive right now and very scarce. And this really leads to the fact that not every project is going to have a tangible or worthwhile ROI. Sometimes you won't be able to compute it, and sometimes it's just not worth it. These are expensive resources and scarce resources, and we really need to think about using AI for the things that actually matter to the goals of the organization. So this is kind of more from a dollars and cents point of view of whether or not we should use AI. But I want to talk also about another thing, which I think many of us have seen before, which is really whether we should use it from a responsibility point of view. So I just pulled a bunch of headlines, and so I'm sure many of you have seen things like this. The first one on the top left is really about the data that we use. OpenAI has this lawsuit right now over infringement. It downloads the internet and trains a model over it. A lot of copyrighted things on the internet. It's kind of being worked out right now, but it's a bigger question about whether we should be allowed to use some of this data for training. The second one down from that is really AI in hiring. It's just fraught with bias and prejudice, and we need to be careful when using AI technology in these very sensitive situations. The bottom left, there's a lot of misuse of data as well, and again, we need to be careful about that. And then kind of in the top right, some of the new technologies like LLMs actually introduce new types of security risks, whether that be just using them for misinformation propaganda, or using them, or introducing new types of security attacks like prompt injection, which, if you use it and integrate it into the wrong systems, could allow an attacker to overtake your system and do pretty malicious things. So one of the things that we think about at RBC a lot is this idea of using things responsibly. And one of the things I'm really proud about RBC is partly because we're a federally regulated financial institution, is that we need to think about risks and doing things responsibly very much, or otherwise we will get fined and it actually have consequences in terms of the licenses that we have. And so we use this framework internally to think about it, and I want to step through this right now. So the first pillar that we think about is privacy. And in fact, at RBC, we only use data that we've explicitly told our clients that we're allowed to use for the purposes that we've told them. And so this is a really important part of being a responsible steward of their data. Second is just security risks. Banks have so much important information that bad actors want to get their hands on. So we need to make sure that we're protecting the data and be good stewards of it for our clients so that some leaks don't happen and you can get things like identity theft or fraud happening. The third pillar is really about being accountable and transparent with our decisions. So for example, we're giving credit to client A and credit to client B. We want to make sure that no unfair prejudice or biases are involved there because it's part of our responsibility as a core part of the economy. Fourth pillar is just related to that fairness. We really want to make sure that we're not introducing unfairness or bias there. And then in the last pillar is really just making sure we have positive outcomes for all of the stakeholders in the ecosystem, from our clients, our communities, employees, as well as the business. So being federally regulated, this is really part of our DNA and part of our organizational structure to do this because we're required to. And I would kind of look to some of the other companies to look at these types of standards and think about whether or not you're using AI responsibly and whether you should be using it in certain situations. Okay, so that was lesson 2, whether or not we should be using AI to solve certain problems. The last lesson here I have is that AI project success is much, much more than the model. I know the model is the super sexy part, the algorithms, that's all we care about, but it's so much more than a model. So I want to start here in this diagram, which you obviously can't read, but I don't even know what half of these things do. And so this is the state of AI, machine learning, and data in 2023. And this really just speaks to the complexity of deploying AI nowadays. It's so complicated that no one person or one kind of specialty can really understand everything. And so we need to think, I also want to point to these headlines that I pulled down, which is kind of scary. It's that basically says something between 50 and 90% of models that get built never make it to production. Up to 90% of models never make it to production. This is kind of blows my mind. But after seeing a lot of these different projects, I start kind of getting the feeling that this is true. And I think part of it is that people always just focus on the models and not really what we need to be focusing on, which is the system. We need to be thinking of the entire AI system and how to deploy that. So this diagram is basically from a Google paper, I think in 2016. And I really like this diagram because it gives a very visceral, visual sense of what we actually need to deploy a system. And so that little blue box in the middle is the machine learning code. So this is like the sexy part that we always focus on. But when you think about the entire system and zoom out, there's so much work that needs to go on the data side, whether it's collection, cleaning, feature extraction that needs to go on, or on the right-hand side of just deploying it at scale, servicing it, managing it, monitoring it. And so when you're thinking about this entire system, if you just have this lone data scientist or researcher trying to build a model in the center, how the heck are you ever going to be able to get to production and get value out of the models that you're building? And so think really hard on this side about the system. Think about the system, not just the model. Okay, so that was kind of more on the technical side about the machine learning is much more than just the models. But I also want to touch upon this idea of risks. because I think this is very pertinent in large enterprises and especially kind of federally regulated ones like RBC. And so at RBC, we think very, very much about risks, but this is also true at any really large enterprise. And part of it is because large enterprises have so much to lose. There's so many ways to really lose value or destroy value in a large enterprise, and this is why we care about risks so much. So there's kind of 4 different quadrants here, and I'll step through each one quickly. The first one is just legal and regulatory. So we mentioned kind of privacy. Legally, are we allowed to do some of the different things? For RBC, regulatory compliance is a huge deal for us. We have different rules we need to follow or else we'll get massive fines. And then also things like fiduciary risk are also really important. And so we spent a lot of time, a lot of effort, a lot of money making sure that these risks are managed. The second one in the bottom left, we talked about a little bit, but cyber IT and fraud. These are key parts. We just have so much valuable data that bad actors really want to get their hands on. And so we need to think hard about managing it both from the outside as well as internally in terms of things like data governance and access and all of those types of things. And to be honest, it does introduce friction to the process. But if you want to deploy things responsibly, this is part of the price that you need to pay to introduce some of this friction so that you can manage things more responsibly and manage these risks. The top right, we have operational resiliency. And again, if you're not from a really large organization, you may not have thought about this that much. But think about going to your ATM or your bank and not being able to withdraw money. This is a really big deal. And so we really need to think about the systems and the processes to make sure that they're resilient, and not just from the technology side, but even from the people side, making sure that there's resiliency there as well. And then on the bottom right, this is kind of maybe a bit more specific to AI. There's some other risks around models about being fair, used for the right purpose, and whether or not just they're strategically aligned with your organization. So I just want to end on this note because this is a simple model, but I think it's proven over and over again very valuable to me. And it's this idea that when you're deploying these types of technology projects, there's kind of 3 main components: the people, the processes, and the technology. And for my entire career, the 2 most difficult things have clearly been the people and the processes. By far, the technology has been a much, much easier thing to handle. And it's partly because the technology is something we can control, whereas the people and the processes are much, much harder. On the people side, things like business alignment, stakeholder management, project management, resource planning, communication, and visibility are all really, really critical things. On the process side, deployment, validation, sign-offs, costs, and risks are also really incredibly important. And one of the things I find is that most people under-index on how much they should pay attention to these different things. And so if I'm just going to leave you with one thing today for you to remember, is that please, please, please make sure you're paying enough attention and enough time to the people and the processes. Because if you do, you're well on your way to an enterprise, successfully deploying AI in the enterprise. Thank you. That's my talk.